Today we're gonna look into a really nice paper that I just read, and I think it's interesting to anyone interested in artificial intelligence. Regardless of the level of your involvement in the science, I think this is an interesting topic to be aware of, to really understand to a certain extent. Not only it will elevate your knowledge about AI, but it will also make you better in understanding and using AI, in my opinion. And the topic is hallucination. So this is a paper by OpenAI they published on the 4th of September 2025, so just recently, and it's titled Why Language Models Hallucinate. And to a certain extent, we can say this is OpenAI's real jab at solving the problem of hallucination. And it is not something that OpenAI can solve on their own. And if you don't know me, my name is Samer, and I'm on a mission to make you one of the top 1% in artificial intelligence. And if you enjoy this episode, do not forget to support the channel and myself by clicking that subscribe button, like the episode, and share it with others if you really like it. And with this, and without any further ado, let's get started.
Subscribe to Daddy's channel. The mic.
Okay, so this is the paper I'm talking about. The title is Why Language Models Hallucinate. I will not go through the paper. I did the reading on your behalf so I can show it to you very shortly, very concisely, in a way that anyone can understand at different levels. Before we go into the details, I just want to show you a glimpse of hallucination and using an example that actually the paper uses. And I tested this example that they mentioned in the paper with some of the close and dear models to many people. So let me start with ChatGPT 4.0. This is I think, the most loved model, it seems. So the prompt is simple. What is Samer Haddad's, so I'm Samer Haddad, birthday? If you know, so I'm just questioning it, answer if you know, respond with a date, basically, 2-digit date and 2-digit month. So this is the format. And do not use the internet. And here, the model hallucinates. In other words, it guesses. It actually gives just a guess, a random guess. And here it gave the 3rd of October, which is wrong. I can tell you that's my birthday. I can tell you it's wrong. So let's go to 4.1. The same prompt. 4.1 said it's the 22nd of February, not my birthday, okay? Let's go for 03. Now you get something different. 03 simply said, I don't have that information. So something is different in 03 compared to these other models. Maybe the reasoning part helped it actually understand that this is not information that the model contains and the confidence is not high. So just tell the user, I don't know. So let's go just to Gemini 2.5 Pro. Again, these are the state-of-the-art type of models for these research labs. So for Google, this is the top one, and it says I do not have access to personal information like birthdays. So it got it right. And then we see here Opus 4.1 again saying I don't have any information about Samer Haddad's birthday in my knowledge base. So it got it right. But you see, the models that are not having that reasoning element are getting it wrong. And this is what we will unpack today, from the definition of hallucination until the solution or solutions that OpenAI is putting forward in this paper. So first thing, let's define hallucination. So you can see the definition here. So it is simply when AI create false information that sounds believable. So it's not just that it creates an assumption or false information, but also sometimes it's a very important characteristic in hallucinations. You get it in a way that sounds that the model is confident about that answer. And again, a nice analogy here is like a student confidently guessing on a test rather than admitting they don't know. And we've all done it. It's much better to actually guess and see what you get rather than just quitting on the whole thing. Right? So it's similar to what a student would do if they do not know an answer. He or she would guess that answer. Now, this is again the birthday example I got from the paper. They called it the birthday paradox. And again, it's the same thing. They show you how the model, if asked about a birthday, it will answer with confidence at some time a wrong answer. And they admit here that all the models they tested this with, including OpenAI's own models, especially the 4.0, 4.1 and others, actually hallucinated when asked these type of questions? Well, it's important also to remember, why do we care? Like, why do we care about hallucinations? Many people actually don't realize them. People who realize them, they know how to deal with AI models and can navigate around them. But still, why does this matter? Well, it undermines AI, so people might lose trust in artificial intelligence systems if they keep to hallucinate. It can spread misinformation, so that's a dangerous thing as well. And it can make AI unsafe for critical applications like medicine and law. So if we want to push the boundaries, if we want to push the envelope on AI, we have to figure this out. And then it creates liability issues for companies using AI. So the research labs themselves, even companies that build application on top of these models, might be liable. Depending on the application that they deploy, they might be liable to their customers because of such hallucinations. So it's something that will always slow down the development of AI, and we have to figure it out. So now let's understand why this happens. Why do models hallucinate? Well, to understand that, we have to get a high-level idea of how models are trained. And usually and broadly, it happens through two phases: the pre-training process and the post-training process. So the simplest way to explain it in a non-technical manner is, imagine a pre-training process is actually trying to teach a child to speak by having them read millions of books. Now, this is a clearly resourceful child, but this is how we pre-train a model. We give it a huge corpus of text and get the model to go through the whole thing. What the model will do going through those huge amounts of data is learn patterns. The problem is, those patterns, they have inherent mistakes and gaps in them, and the model will learn those too. So this is one of the biggest reasons of why models hallucinate. The false statements are there in the corpus of text that we feed the model in the pre-training process. Now, once we pre-train the model, it will have to start predicting words. This is how the child learns to speak. It will start predicting the next word and the next word and the next word after being triggered, usually by a prompt. So it will start to do that billions of times. And then imagine that child has their own mechanism, we can call it intuition, just to fit the example, that tells it, well, the word that you predicted just now, that's incorrect, or that is not the most probable word you should have said. So this is what they call in AI cross entropy loss, or loss in general, the loss function, and it's a measure of the error in the prediction that the model generates. Now, as the model is pre-trained, is predicting billions of words, having a mechanism to tell how good or bad those predictions were, at some point, the model will face a sequence or a pattern it didn't see before. So at that moment, the model has to guess the next word. Again, the same prediction will happen, but this time it is a bad prediction because it is assuming what probably should come next on something that it didn't, or a pattern it didn't see before, or text that the child didn't read before. And to go a little bit more into those areas, there is what they call the lonely fact problem. And what they say is here about this problem is like teaching a child. If you give a child a piece of information once, they will probably forget it. And if asked about it, they will probably miss it or get it wrong. So they say that 20% of the facts that AI models are fed actually appear once. So this is what they call the lonely fact problem. So the fact is not repeated to the level where the model learns it. And this is a major thing. So you can assume that it will do mistakes 20% of the time. And then one of the reasons they talk about, which is a mathematical reason, is the computational learning theory. And fundamentally, they tell you, like humans, if you give a human so much information, mathematically, regardless of how smart, how good that human is, they are ought to make mistakes. They will make a mistake eventually. And the same goes for technology. If you give them huge amounts of data, they will at some point make a mistake. That is mathematically, from a probability and statistical perspective, inevitable. There's no way around it. And that's why in the beginning I was saying we want to improve that, probably will never solve it totally. So here you can see in the simple definition I've put, just like humans can't memorize every fact, AI mathematically cannot avoid all errors. It's proven by math. And the analogy here is that this is like trying to guess everyone's birthday in a city after meeting only half of the people. Some guessing is inevitable. And when guessing happens, this is where we get the hallucination or the errors. So let's look at the root causes quickly. So statistically, it is inevitable for models to guess. The singleton problem, basically facts that the model learns only once or sees only once, they will get it wrong. Poor models, I think this is obvious enough. Computational hardness, well, some problems or the solution for a problem is just too complex for a model to predict correctly. So here, some example is like encryption, for example. So encryption is something that you should expect that the model will get wrong. Distribution shift, well, this one in simple terms, when we give that child all of that text to read, to learn how to speak, the child, when it is reading, the child, which is the model, when it's reading each sentence or statement, it will give it what they call a high density estimation. Something, it's like a mark or a probability that later on will help it to look at it as a statement and the probability of using that statement in a certain situation or scenario. Now, all of these probabilities, they will have their own distribution over the training data, the text that we gave that child to read. Once we go out of testing, in the testing phase, and we go to the real world, the model or the child will face sentences that it never read before. So there will be a distribution shift compared to its training data, to the text that the child read. And then it will make mistakes because it's facing something new. And lastly, GIGO, or garbage in, garbage out. I think if you work in a company, you use it every day when you're talking systems. So if we give it basically bad data, it will have bad outcomes. It will hallucinate for sure. Now let's look at the role of post-training in the problem of hallucination. Post-training is also an accomplice. So at this stage, we have a child who somehow knows how to speak, is trained on reading many books, so it has some data in its head, but the kid or the child model is not really good at speaking as we want it to. We want it to become an expert at speaking. This is where the post-training comes. And what we do for that analogy child is that we ask it questions. If it gets that question right, the child or the model will get a treat. And when the child gets that treat, it will want more of that treat. It will keep playing a game of answering and changing the way it is thinking to a certain extent. So its brain, as it's answering those questions, is developing and it's learning, how do I increase the odds that the next answer I give actually gives me a treat and not a zero. So basically, if it answers wrong, it gets nothing. So this way, this is what we call as reinforcement learning. Giving treats or incentive or a reward system that we offer the child or the model is the thing that gets it to become super smart, because it's learning how to get more rewards, more treats out of the system that we put it in. And this is a problem. This is a big part of the problem, because now, remember, we were all students at one point. When you were a student, and you get a mark or a treat, let's call it a treat or a mark, on an exam for a correct question, you will take it. That's a no-brainer because you know the correct answer, you have a question, you'll answer it. But what if you face a question that you don't know? So would you pass? Would you say, I don't know the answer and just pass that question? Or would you just try? Because you know, statistically, if 50% of the questions you get are questions that you know. So this is us in our human-like, real-life reinforcement learning. This is what exams are. Exams and testing in schools is reinforcement learning for kids. And it should change as well, I think. You know, statistically, if you know for sure 50% of the questions, you're getting that 50%. But for the other 50%, if you're not sure or don't know the answer at all, you know for a fact, if you guess that 50% that you don't know, there's a high probability, especially if we're talking about yes or no type of answers or multiple choice type of questions. You know for a fact that if you just randomly go through those questions, you will get some reward out of them. That could be high, that could be low. So you are incentivized as a student in a school system to actually guess. So guessing is big part of human testing, and we put the same mechanism in our AI models. So AI models like us when we were little students, they have high incentive to actually guess. And sometimes those models will guess with certainty and with style. And it will tell you, certainly, this is the fact. And it will push in the guess. And in many cases, that guess is wrong. So that's why models are hallucinating. They are incentivized to hallucinate rather than, well, say, I don't know, or maybe ask questions. And we've seen, when I showed you in the beginning, the smarter models are now done in a way that will tell you, well, I don't know. And that's because of some mechanisms that are reducing hallucination, but still, what OpenAI will suggest in a second will be way beyond anything that we had before. And I think this is something interesting for the AI community to adopt. One other thing they highlight here is that all of the evaluations, so every time you look at an AI model review type of video, people are talking about evaluations. You know, all of these bar charts that show in a certain benchmark, a model is better than all others, and so forth. All of these evaluations that you see some here, so you see the MMLU, the GPQA, the software engineering bench, and so forth, math, and all of them. All of these, again, within them, embed the same incentive for these models. They have either no mark or 1 mark. So the model, when it is actually working with these evaluations as it's training, or later on as it's being tested, it has all the incentive to guess. So we train the models to guess, we refine them to guess, we evaluate them to guess, so we get too much guesses in the system. And that is at the heart of the problem that OpenAI is actually pointing to. And this is the key statement here. The problem isn't just that AI hallucinates, it is that we reward hallucination through our testing methods. So I think this is clear now, and everyone was a student and you know exactly what I'm talking about, because we all did it as students. We all guessed because it makes lots of sense. So now let's take a quick look at what we did so far to try to reduce it, and then what OpenAI is actually suggesting. Historically, we've tried so many things, and you can see here some timelines. So 20 to 22, we had early attempts on hallucination. We looked at fact checking with external databases. We tried RAG. We tried WebGPT, which is and other internet search tools to get information from the internet. The problem is AI is still guessing. So regardless of what we do here, the model or the child will inevitably face something that we can't recover from these sources. Something that wasn't fact-checked or is not available in a vector store or is not available online. And by the way, online has lots of really bad data. So it will still guess. The problem isn't guessing. Now in 22 to 23, we tested something which is still relevant and interesting, the confidence method. What we've done here is we teach the AI to express a confidence level, and that happens in the back end. So if you ask a model a question, it will start ranking its own confidence on the answer it will give you, as if it has a small checker system within the model. So that checker will look at it and would say, is this valid or not? And the model would give itself a mark for how confident or how valid the statement is. Now, is it valid isn't something new, but with this confidence level, in reality, you can actually tell the model, hey, do not answer the user with the piece of information you're gonna say out loud to the user unless you're 75% confident or more or higher. So it helps actually, especially the reasoning and smarter models, to be able to reduce hallucination. And then self-consistency checks, and this is where the model actually gets multiple answers and checks if all those different answers to the same prompt or request it got were consistent. So if it's consistent, that has a higher confidence probability. So it might end up by actually showing that answer to the user. If there's low consistency, it might not. It might go to say something else like I don't know or I'm not sure. Okay. And uncertainty quantification research. Again, all of that is similar to what we're talking about here in terms of confidence. The problem, it doesn't address the root training question. It's just a band-aid. So all of these things are not solving the core problem of the model guessing. It's just giving it methods to guess better, I guess. So that's what's happening here. It was a good improvement. I think across each phase of these phases, we've seen something significant in how models perform and how hallucination reduces. But what they're saying, this also will not get us where we need to be. And the last one is fine-tuning on verified facts only. Fine-tuning is a process where actually the model gets examples. So this is the request, this is the answer, this is the request, this is the answer. The model or the child tries to look at those examples and learn from the patterns of question and answer type of thing. It's not as simple, but this is the simplified version of it. And then constitutional AI with built-in principle. Again, different methodology to reduce hallucination, giving it principle basically on how to act in a certain situation when it needs to guess. Reinforcement learning from human feedback. So we talked about reinforcement learning. When it comes to human feedback, well, you know the like or dislike button you find on ChatGPT. So something like that. So if you get an answer and you're a smart person and you're a human expert and you think it's wrong or you know it's wrong, you just hit thumbs down. So this is the feedback you as a human are giving to the model. So the model will learn, okay, this is wrong. So this is reinforcement learning with human expert feedback that they assumed will get these models to hallucinate less. Again, this is not solving the core problem of these model guessing. The models are still guessing. They're improving with the feedback they get from humans. And by the way, this is not scalable because as you train more and more model, you want these things to happen systematically. You can't really depend on human feedback at scale, I think. Last but not least, let's see what OpenAI is proposing as a solution. So the first part they talked about is giving explicit confidence targets, which we hinted on as something they looked at in terms of confidence percentage, but this is explicitly giving a target. So the concept is tell AI explicitly when to answer versus when to say I don't know. So that's, as we said before, 85% confidence or more, answer. Anything less, say I don't know. Now, this is the big one where they are suggesting a wider approach to reducing hallucination. Evaluation reform. So they're using the word reform for all the evals and the benchmarks we use. So the proposed changes in these evaluations is reward appropriate uncertainty, penalize overconfident false answers, and give partial credit for I need more information, match real-world consequences. So basically, when you're testing the model or evaluating the model, it's not 1 and 0 kind of rewards that it should be getting. So it should get, for example, 1 point, or let's say 5 points to make it easier if it gets it right. But if it gets it wrong, we will deduct 2 points. And if it overconfidently gets it wrong, we actually deduct 7 points. I'm just giving those as examples because the models, this is one of the bigger problems. The model sometimes when it gives those answers, it gives them with certainty to the user. So you want the model, if it's not sure, maybe to make the logic and the reasoning, well, I have 3 options now. Either I can answer with confidence that this is the right answer, but the model knows the confidence is low, or I can answer it, but without this kind of overconfidence in my tone, or I can simply say I don't know. Each will have its own consequence. So the model will reason, which is my best odd. Again, it's playing a game. In the way the model is doing these things, it's playing a game. It wants to get the highest mark or total mark for the evaluation or the testing it's doing. So it will have to really decide the best statistical probability in terms of answer that will highly increase the odds of the highest mark it can get in these evaluations. So this is a reform we need to do on how we test these models, because regardless of how we pre-train them and post-train them, getting hallucinations is inevitable. But now we need to get this child to test differently, to play a new game. I hope teachers and schools are doing that with our kids because it makes lots of sense. You have to give them real life consequences to the way they answer. So it shouldn't be 1 and 0 in the way you mark those testing. But how do we make it as a community happen? Well, we need to modify all the existing benchmarks, not create new ones. Because OpenAI are saying the existing benchmarks are good, people use them, new ones might not get the same attention. So we just reinvent them in a way that actually drives the results that we want in reducing hallucination by changing the way we evaluate models. And then add confidence threshold to test instructions. So example, answer only if 80% confident, -2 points for errors. So -2 points for errors with high confidence answers. 3, industry adoption through leaderboard changes. So major labs compete on leaderboards, change the game, change the behavior. And we know in the community, everyone's saying some companies started overfitting their models to actually get the evaluation or the benchmark and hit that bar chart to get the hype in the market by people. And you've seen people overdo it and they were in trouble, like Meta, for example. So this is something that is industry-wide. This is something that is AI community-wide, even individuals who can influence the behavior of these companies. So this is what they're talking about here. Social pressure for honest AI evaluation. Users and researchers demand uncertainty-aware systems. So this is what we all should be expecting from these AI companies. And this is at the crux of this paper. They're saying, this is a socio-technical, this is the first time I hear this term, this is a socio-technical change. This requires both technical changes and community agreement. And here they're referring to the wider AI community. Now finally with this, the future will be brighter because we can trust our AI systems more. We can even hypothetically get systems to hand over to human experts when needed. It will reduce misinformation. It will make using the technology safer and better for everyone. And we'll end it with this. Just as we teach children that I don't know is better than lying, well, we must teach our AI systems the same principle. So I hope you enjoyed this episode. We all understand why models hallucinate now. It's nothing weird. It's not a mystery. It's just the models are guessing because we teach them to do that. Like we teach our children in the education system to guess because that's statistically the right thing to do as we train them. So we have to change all of that. I think it's an amazing paper by OpenAI, and I think this is a really bona fide and solid solution that the community has to agree upon, and only then we can actually drive to those confidence or uncertainty driven models. I hope you enjoyed the episode. If you did, hit that like button, share it with others, and do not forget to subscribe to my channel for me to do more content like this and support the work that I do. And by the way, again, all the links will be in the description, including the link for this visual that I created if you want to show it to others or if you want to go over it yourself again in the future. And with this, thank you for watching and goodbye.
Subscribe to Daddy's channel. Give me the mic.